Hello, my dear students. Welcome to lecture number 9 on light reflection and refraction. Myself, R.V. Jambagi. In the last lecture, dear students, we came to know about the image formation by convex mirror and the summary related to image formations in different kinds of mirrors. They are plane, concave, and convex. In this part, you are learning sign conventions for spherical mirrors, mirror formula, and linear magnification. Let us study those one by one. First one, sign conventions for reflection by spherical mirrors. While dealing with the reflection of light by spherical mirrors, we follow a set of sign conventions. We follow a set of sign conventions or sign agreements called mu Cartesian sign conventions. So these are very much helpful in solving the problems in many ways. Okay, only the problems we are finding perfect path to understand the spherical mirrors easily. This is the picture of a concave mirror along with the object and image and rest things are mentioned here. Let us try to understand sign conventions, what exactly they say. The first one, the object is always placed into left of the mirror. So the first convention is object should always placed into left of the mirror. This implies that light should fall on the mirror from left side. Note this. What exactly the first convention suggests? The first convention says the object is always placed into left of the mirror, which means light should fall on the mirror from left hand side. So this is the first rule. Let us try to go back into the diagram here. So what it suggests? So assume this is the object AB which is placed according to the first rule. Object should be placed on left hand side or left side of the mirror, which implies the light should follow or light should fall from left hand side to the mirror. This is the first agreement or first convention. I hope you got the first convention right. Now the second convention, all distances parallel to the principal axis, all distances parallel to the principal axis are measured from pole of the mirror. I repeat, all the distances parallel to the principal axis are measured from pole of the mirror. Let's go back to the diagram. So this is the pole of the mirror. Here it is, the pole of the mirror. This is the point. All distances measured from the pole of the mirror which are parallel to the principal axis. So whatever the distances you are measuring, that is with respect to pole of the mirror. Okay. All the distances said that parallel to the principal axis. Parallel, all the distances are parallel to the principal axis are measured from pole of the mirror only. So this is some centimeter, this is another some centimeters, so on like that. All the distances should be measured from pole of the mirror to this. This is how we are measuring the distance in case of concave or convex, in other words spherical mirrors. I hope this convention is well. Now I am taking combinedly 3 and 4, all the distances measured to the right of the origin, all the distances measured to the right of the origin or along positive x-axis. Along positive x-axis are taken positive. Fourth one, all the distances measured to the left of the origin or along negative x-axis are taken negative. So positive, negative. Again, they are the conventions. All distances measured to the right of the origin means what? Along the positive x-axis are taken positive and along negative x-axis are taken negative. How? Let us see. So all the distances on the right hand side of the mirror, that is taken positive. So this is the positive x-axis line, this is the positive x-axis, this is the negative x-axis. Better if I draw like this will be give better idea. This is the positive x-axis, this is the negative x-axis. Here positive x, keep it as x only. Here negative x, they taken as x dash. Okay, this is positive, this is negative as per the convention. Means all the distances are measured positive x-axis, they are taken positive only. Here it is mentioned the distance is towards right of the origin, that is taken as positive. The distance is towards left, that is negative. So whatever the distances are coming here, they are negative. The distances on the right side, that is positive. I hope you got these two conventions correctly. Now again I am taking combinedly fifth and sixth. The distance is measured perpendicular to the and above the principal axis. The distance is measured perpendicular and above the principal axis or along positive y-axis are taken positive, and the distance is measured perpendicular to and below the principal axis, that is negative y-axis, are taken negative. Let us go back to the diagram here. If you are measuring the distance that is on along y-axis on this side, that is positive, and this side, that is negative. So above the principal axis, that is taken as positive, and below the principal axis, that is taken negative. All the distances perpendicular to the principal axis taken as positive, and below the principal axis taken negative. So these are the few rules. As I already mentioned, rules are very much useful in solving the problems. Not only the solving problems, they are needed to understand complete understanding of spherical mirrors. Okay, dear students, let me recap those conventions again. So the first convention suggests the object should be kept on left hand side. It implies light should fall from left hand side to the mirror. The light should fall from left hand side to the mirror. So this is the first rule. And second rule suggests all the distances which are parallel to the principal axis, parallel means like this, parallel to the principal axis, are measured from pole of the mirror. All the distances parallel to the principal axis measured from pole of the mirror. Next rule, that is the distances you are measuring towards the right hand side, or say right of the origin. If you take this as a origin, then this has to be the right hand side. and this has to be the left hand side. So the distance is measured to the right of the mirror or positive of the origin you may call, then that is taken as positive, and on the left hand side, same to the left hand side, that is taken negative. The distance is towards left, taken negative. Distance is towards right, taken positive. I hope you got this. And the distances perpendicular to the principal axis, means which are above the principal axis, that is taken negative. On both sides it is going to work. The distances you are measuring perpendicular to that, perpendicular to the principal axis, so this is taken as completely positive. The portion above the principal axis taken positive, the portion below the principal axis, that is taken negative. I hope you got these things right in your mind. Again, the suggestion is just recap these things, then by that you can understand these things cleanly. The next part and the final part of this lecture, that is mirror formula and linear magnification. First one, mirror formula. Mirror formula gives us the relationship between the object distance, that is denoted by u, the image distance v, and the focal length f. So here I am not deriving the equation. The derivation part you are going to learn in the future years. So at this point of time I am taking the relation directly by defining object distance, image distance, and focal length. Object distance is the distance between pole of the mirror to the object. That is the object distance. The distance between pole of the mirror and the object is taken as object distance, and it is denoted by u. Image distance is the distance from the pole of the mirror to the image. The distance between pole of the mirror and the image is taken as image distance, and focal length is already known, that is the distance between principal focus f and pole of the mirror p, that is focal length. So it can be related as, that is 1 by f is equal to 1 by u plus 1 by v. This is the relation, and this is known as the mirror formula. 1 by f, which is equal to 1 by u plus 1 by v. This relation is valid for all situations, for all spherical mirrors at different positions of the object. At different positions of the object, this relation is valid in all situations for all spherical mirrors. I hope you are getting this. This helps us again in solving many problems in optics. This relation is helping us in solving many problems in optics. So that's why this formula is important. I hope you got this relation right. Next part, that is linear magnification. Linear magnification of the mirror is the ratio of size or height of the image, size or height of the image to the size or height of the object. It is the ratio of height of the image to the height of the object, or size of the image to the size of the object. This is denoted by the symbol m. Small m denotes for linear magnification. This gives, actually linear magnification gives how much magnified the image is. This is the physical meaning, even though we defined in terms of ratio. This gives how much the magnified image is there with respect to the object, how much magnified the image is. That is what the linear magnification is all about. So that is given by m is equal to h prime upon h or h dash upon h, where h dash is the image height, h is the object height. Height of the object is h, height of the image is h dash. That is the ratio of image height or height of the image to the height of the object. In terms of object and image distances, it can be written, this is the first formula, h dash upon h. And secondly, you can take in terms of image and object distances, m is equal to minus v upon u. Minus, again, it follows the conventions. In the end, we got this kind of formula. As I already mentioned, I am not deriving this, so you are learning there in the higher classes. Anyway, I am taking those relations directly. By that we can solve some amount of problems here at this point of time. Okay, m is equal to minus v by u, which is equal to image distance, which is minus, divided by object distance. This is about linear magnification is concerned. I hope you got all the points discussed in this lecture, and I am giving the suggestion once again, please follow these steps, these agreements repeatedly. By that you are getting some comfort on that. Without that, the solution of the problem much impossible. Why I am saying this, please note all these words, my dear students. I repeat, mark my words, these things are essential in solving the problems which I am going to discuss in the next period. I hope you are doing that. This ends today's lecture on light reflection and refraction. With the problem section, I am going to meet you in the next video. Till then, take care of yourselves. Bye bye.